Hi everyone, today is lesson 3, no real solutions. Sometimes when we solve quadratics, there are no solutions. So we're going to see what that looks like in terms of looking at a graph, and also when we solve it, doing our methods of factoring, completing the square, and using the quadratic formula.
Okay, looking at our notes for lesson 3, our lesson today is no real solutions. Learning target is I can solve quadratic equations and identify when a quadratic has no real solutions. So when we solve quadratics, we know that it means we're looking at our x-axis where a parabola intersects the x-axis. Well, sometimes that doesn't always happen. So again, remember when we solve quadratics, we are looking for the zeros or x-intercepts or roots. All of those mean the same thing. The solutions are found where the parabola hits the x-axis, but what if it doesn't hit the x-axis? So right below, you can see an example of a quadratic function that has no real solutions, meaning it doesn't intersect the x-axis, and sometimes that happens. So from a graph, really easy to determine if there's no real solutions. You just look, if it doesn't intersect that x-axis, then you know. But looking from an equation, there's a little more to it. So it says solve the following quadratic. It says y equals x squared plus 5x plus 8. Now, whenever we solve a quadratic, we set our equation equal to 0 because we're trying to figure out where y equals 0. That means where it intersects the x-axis. So we can't factor this, okay, because factors of 8 that add to 5 don't exist. And also, you will never be able to factor a quadratic if it doesn't have solutions. Sometimes you're not able to factor something, but you can solve it by completing the square or doing the quadratic formula. That's different. That's okay. But there will never be one. If you can factor it, then it has a solution for sure. But really, we know if there's no real solutions by solving it by either completing the square or using the quadratic formula. So I'm going to tell you right now, this example of the quadratic has no real solutions. So let's go ahead and try to solve it and see where we're going to have a hiccup and notice that, oh, this doesn't make sense. We're not going to have any real solutions. Okay, so first thing is if you pick up your calculator and you go to y equals and you type in x squared plus 5x plus 8, and you press graph, you can tell right away that quadratic does not intersect the x-axis. However, a lot of times it will say prove it algebraically, meaning you have to show your work. So let's solve this by completing the square. So this first one, we always replace the y with a 0 because that is what we're finding. We're finding the zeros. Okay, now I'm going to kind of jump ahead a little bit. So actually, we first have to take half of our b term, so 5 divided by 2, and then we're squaring that, okay, which is kind of a weird number. So 5 divided by 2 is 2.5, and when we square that, we get 6.25. Okay, so now we have to add that and subtract that. And then group our first 3 terms together. By the way, having a decimal when we complete the square can still work. So don't think that having the decimal indicates that there's no real solutions, because there are ones that have decimals and there are solutions. Okay, now we have to factor. So this is kind of weird. Factors of 6.25 that add to 5. That's kind of complicated. I'll give you a little hint here. Whatever is in the parentheses is always half of your b term. So half of 5 is 2.5. X plus 2.5 squared. Because if you do 2.5 times 2.5, that's how we get our 6.25. And when you combine like terms, you get that 5x. Now we have to simplify negative 6.25 plus 8. And we get a positive 1.75. Now we are solving it. Now, I don't know what's wrong with me, but I always like the 0 on the right-hand side when I solve. Okay, so we need to get that x by itself. So we subtract 1.75, subtract 1.75. So I'm left with x plus 2.5 squared equals negative 1.75. Now, how do I get rid of that squared? Oops, I didn't mean that 0 in front. We take the square root of both sides. Okay, I just want to make sure my equation editor is in here. There we go. Okay, so I take the square root here, and I take the square root here, and I get x plus 2.5 equals plus or minus whatever I get here. So I'm going to take the square root of negative 1.75. And this right here is what tells us there are no real solutions. In whatever calculator you're using, it should say there is an error or that there's a non-real answer. That's because not in SAIL Algebra 2 Trig, you cannot take square roots of negative numbers. So I'm just going to say error. So then I'm going to write no real solutions. So that's the key here. You know that there is no real solution if you're taking the square root of a negative number. Okay, now let's prove that that same thing is going to happen using the quadratic formula. So my b value is 5. My a value is 1. And my c value is 8. My a value is 1. Copy and paste, my favorite thing. Okay, negative 5 is just negative 5. Let's type in everything that's underneath the square root. Do not type in the square root. And we should get negative 7. All over right here. No real solutions because there is a negative under the square. And that's it. Okay, so next part. It says solve the following quadratics by factoring, completing the square, or using the quadratic formula. Some will have no real solutions. So I think I'll do 2 of these with you, and then you're on your own. It is up to you how you solve them. Factoring only works with some, but if it works, it's probably the easiest way to do it. Second method is completing the square. And the third method is the quadratic formula. Technically, completing the square and the quadratic formula will work with any quadratic. However, it's going to be easiest if you can factor, and then the other, if that you can't factor, then just pick which method you prefer. So let's look at number 1. So we should first set our equation equal to 0. Oops. Now, I personally like to check to see if I can factor. So GCF, I don't see a GCF. Let's look at dots. We have a binomial, we have subtraction, and both of these are perfect squares. So yeah, we can do dots. So that means we double bubble. For dots, we always have opposite signs. And you take the square root of 49. Now, we make a t-chart, but I can't do that on my Google Docs. So we are going to set each factor equal to 0. So x plus 7 equals 0. And if we solve that, we subtract 7 from both sides, we get x equals negative 7. Then we have x minus 7 equals 0. Add 7 to both sides, we get x equals positive 7. So my solution, negative 7 and 7. That means my parabola intersects the x-axis at negative 7 and 7. See, pretty fast when you can factor. All right, let's take a look at number 2. So we should always check for factoring. So GCF, don't see one. Dots, can't, it's not a binomial. Regular trinomial factoring is not going to work because we have that 2 out in front. But we could see if we can slide, divide, slide. So just to check to see if we can do it, we would slide the 2 to the 12, right? And we would get 24. So we would have to find factors of 24 that add to 7. Now think about that for a minute and see if that's possible. And you should realize that it's not possible. So we cannot factor for this one. So you could either do completing the square, however, you really can't actually, because we haven't learned, there is a way to do it, but I haven't decided that that's a really important part for you for next year. But we've got this number out in front. So when you have that number out in front and you can't take it out for a GCF, let's just stick with the quadratic formula. Okay, so my B value is -7. The A value is 2. And my C value is 12. A value again is 2. Now we simplify, a -7 turns into a +7. I'm going to type in everything that's underneath the square root sign, but not the square root. And I get -47. And in the denominator, I get 4. Stop right there. This is no real solutions because there is a negative under the square root. Not all of them are going to be like that. Okay, so if you do get a positive number under the square root, try to simplify it or simplify the radical as we learned last week. All right, I want you to try 3 through 5 on your own. All right, check your work with my work. Number 3, you could factor. We got -8 and 10. Number 4, you could have done the quadratic formula or completing the square. I chose to do completing the square. You should get no real solutions. And number 5, I decided to do the quadratic formula. You can also do completing the square here. And this one was one that we do have solutions. However, you did have to simplify the radical. We had radical 48, and then simplify your final answer to 3 plus or minus 2 radical 3. And that's all I have for us for today. Make sure you self-assess for today's lesson.